Okay, we'll just start off with a little bit of housekeeping. So if everyone there on the call can just mute their mic, and if you can turn on your camera as well, we'd appreciate that just before we start. Mm-hmm.
I was just doing some gardening. Okay.
Oh. Okay. So good evening and a warm welcome to everyone. This is the first in our autumn winter series of Passivhaus Live. We carried out the first season in the spring of this year, 2021. And my name is Barry McCarran, the current chairperson of the Passivhaus Association of Ireland. The PHAI, or Passivhaus Association of Ireland, is just over 10 years old now, this year just gone by, and we're the body that has been representing Passivhaus on the island of Ireland, promoting the benefits of good energy design based on the Passivhaus principles across the construction sector here in Ireland. Passivhaus design is a proven quality assured route to delivering high performance design, which is paramount against the backdrop that we have at the moment of a declared climate emergency here in Ireland. We've just seen the fourth assessment report come out. So against that backdrop, we've a requirement, an ever increasing demand to reduce and deliver low carbon buildings. And now in recent months with the pandemic, we're starting to see now the emergence of how important ventilation is in buildings. And again, this is right at the heart of the Passivhaus standard. So it's really the mission of the Passivhaus Association of Ireland to promote, educate and facilitate and meet the growing demand for the Passivhaus standard here in Ireland. So the PHAI is part of a wider global network which forms an international affiliation which is known as the International Passivhaus Association. And again, like our series before, it's really now at this point, I'll sort of invite everybody, if you enjoyed tonight and you really, like what you're seeing, see the nice projects over this whole series, I'd really invite you directly to come and become a member of the PHAI. It's nominal money to join, and it'd be good to have more people coming in and growing the vibrant group that we have here in the PHAI. So just to give an overview of the program for tonight, the program for those who haven't maybe attended previously follows the same format. So we're going to have an introduction now of our guest speaker for tonight. And then after that, we'll have a bit of a Q&A, and some of us in the background will pick up any questions in the chat. And then after that, we'll have a breakout session for 7 or 8 minutes or so. So I encourage people to not drop off, to stay online and see who you get chucked into a room with, and hopefully, have some interesting interactions. And then we round out, and the aim is to do all of this within an hour, to have a short, sharp, snappy presentation. So it's over to Simon now, who's going to introduce who we have tonight.
Thanks, Barry, and good evening, everyone. So tonight we have Niall Crossan, who's going to be talking about his own Passivhaus project. I'm sure any of you who are working in Ireland will know Niall and his background. So Niall is Group Technical Manager with Ecological Building Systems. He holds a degree as a Bachelor of Technology and a Master's of Engineering Science. He's also a certified Passivhaus consultant and board member of the Irish Green Building Council. Niall has provided guidance on several national standard committees and provides input to several working groups within the IGBC and the UK Centre for Moisture in Buildings. His expertise is in the area of building physics, energy conservation, hydrothermal analysis, airtightness, natural insulation and vapor diffusion, open constructions. So lots of good technical stuff there that in the Passivhaus sphere we're all really interested in. Niall has provided guidance to many award-winning new build and retrofit projects in Ireland and the UK. And he has co-authored and authored chapters for a number of low energy building publications, including the Passivhaus Handbook and the Passivhaus Designer's Manual. His own Passivhaus features in the latest issue of the publication Understanding Passivhaus by Emma Walshaw. So we're very much looking forward to Niall taking us through the learning from his own project. And before I hand over to Niall, if I could just ask everyone to put any questions into the chat. I'm going to try and keep track of that, and we'll get through as many of those as we can after the presentation. So over to you now. Thanks. You're muted now.
Sorry. Can you hear me now? Great. Okay, thank you, Simon. I promise I didn't write all that in that introduction. I'll just get this presentation started now. Can you see that okay? Is that all right?
Yeah.
Yep, great. So yeah, good afternoon, everybody. And firstly, I'd like to thank PHAI for inviting me to speak this evening. I've seen the other presentations you've been delivering, and they've been really outstanding, and it sets the bar very high. Just to give a brief background on the company I work with, Ecological Building Systems, our parent company is called McCann & Byrne, which was established in 1906 as a small merchant shop in the village of Athboy in County Meath. And over 100 years, it evolved and became a major importer of building materials to Ireland. In the year 2000, we launched Ecological Building Systems. That's when I joined the company. And we started working with companies like Proclima, Gutex, other companies who would be pioneers in their fields of airtightness or natural insulation materials. One thing we realized very early on was these are technical materials that require training and education. And we set up a training center, and that's central very much to everything we do, is training, education, and supporting end users and designers. My presentation this afternoon will focus on my own house, but I will give some background information also about embodied carbon and energy and why that's so important. So I'll be speaking with my Green Building Council hat on, as well as Ecological Building Systems. But in the presentation, I'll give a brief background on the project, why I selected the materials I selected with some details, some of the challenges that I had to overcome, and the results at the end. There's a lot to go through, so this will be a whistle-stop tour, but hopefully I'll keep the schedule. I know Barry and Simon will pull me off the screen quickly enough if I'm in trouble. So I built my house in Cavan, that's where I'm from. This is a picture I took during lockdown one morning last April. I was out for a walk with the dog, and my house is just down here. I'm overlooking 3 lakes here where I live. My father owned the land where I built, and I was very lucky and blessed to have inherited a site about 20 years ago. And really, I wasn't sure if I'd ever build, but 3 years ago, I started that process and started building. Just one thing I wanted to begin before I go into the details of my project was it's World Green Building Week this week, and this week, this year, the focus is on building resilience, which I think is very topical and relevant, and also ties in well with my presentation about my house and building with more sustainable materials. And there are a number of events on for World Green Building Week that I'll give a link at the end that would be well worth referencing. In terms of embodied carbon, it's often cited as the blind spot of the construction industry. A guy called Anthony Pack, who is really well informed, he coined this phrase a few years ago, and it really stuck in my mind because it really clarifies the issues that we're facing in terms of embodied carbon. And between now and 2060, the building industry is poised to add 230 billion square meters of new construction worldwide. And this means we're going to double the amount of buildings we currently have on the planet over the next 4 decades, which is absolutely phenomenal when you try and comprehend that. And to put that into perspective, we're constructing the equivalent of an entire New York City every month for the next 40 years. So embodied carbon, this will be responsible for almost half of total construction emissions between now and 2050. So as Barry referenced earlier on, operational energy is critical, and we have addressed that to a large extent, and Passivhaus goes some way to absolutely nailing that. But it's the embodied carbon now is proving the point that we really need to address and get a hold of, because these upfront emissions are the emissions that we're emitting now, which are going to be in the atmosphere for the years to come. And if we are in a climate emergency, these are emissions that we must tackle urgently. This is just an infographic I saw a few years ago in the UK at a campaign for building with wood. And it showed this well-known project called Brightport House, which is the first mid-rise CLT building in London. Originally, if this was built with concrete, it would have emitted over 1 million kilos of carbon in the construction process within the embodied carbon materials. But because they use cross-laminated timber or CLT, it actually sequestered over 1 million kilos of carbon. So if you think about that, that's locking up the carbon that would otherwise go into the atmosphere. And instead of just burning the wood in a stove or something like that, using it for something that's much longer lasting and with much better environmental output. So those of you listening this evening that are architects and designers, you have a key role to play in tackling embodied carbon. Because if we look at this graph from the World Green Building Council paper, it's really at the design stage. That's when we have the most potential input in reducing the embodied carbon of projects. Well, if we build clever and build less, of course, if you build nothing, that's going to have the optimum effect in terms of environmental impact, but we have to build. If we leave it till too late in the process, we can't have that impact. So as passive house designers and as homeowners and builders, it's really at the design stage. This is when we have a key role to play, to build clever and optimize material usage, and then build efficiently using low carbon construction technologies. And then over the life cycle of the building, it's the operation and maintenance that has the environmental impact. And insulation, as well as standard building materials, does have an environmental impact as well. Of course, insulation is there to reduce heat loss, which is very beneficial. But different insulation types can have significantly different emissions. For example, you see extruded XPS compared to, say, cellulose, whereas cellulose is a negative, or it's a carbon sequestering material. We can see XPS is a significant carbon emitter. So the materials we use, if we can use insulation materials that not only reduce heat loss, but also sequester carbon, we have a double whammy in effect, when we're locking up carbon in the material and we're reducing the operational energy of buildings. So most recent central bank figures in Ireland, this suggests, now this is very debatable, but we need about 34,000 houses in the south of Ireland per annum for the next decade. And Ronan Lyons would say we need 50,000, but let's say we need 34,000 houses. Research also suggests, on average, carbon emissions associated with the construction of a new house in Ireland is around 30 tonnes. These are the upfront emissions. This will result in over 1 million tonnes of emissions each year from building. This is not to do with operational energy, this is just the materials. And concrete or cement account for about half of this. Concrete emits about almost 3 billion tonnes of greenhouse gas emissions annually. It's responsible for 8% of global emissions. And if it were a country, it would be the third greatest emitter worldwide, after China and the US. And since the introduction of NZEB in 2019, embodied carbon now accounts for the major proportion of emissions, approximately 50% of the total life cycle emissions of new homes. So are we looking at the target and missing the point if we're building with carbon intensive materials, low energy homes? And according to the Irish Green Building Council, unless embodied carbon is tackled, building 500,000 houses as envisaged by the National Planning Framework and all associated infrastructure will result in 38 to 50 million tonnes of carbon emitted up to 2040. And our Climate Change and Low Action Carbon Planning Act requires our emissions to fall by 3.5 million tonnes per year by 2030. We need to commit to net zero carbon building and account for operational and upfront emissions and encourage the use of more sustainable materials and design principles if we are going to have any hope of meeting these targets. So in terms of my own house, just going into it as a case study, I lived in a village nearby and I used to cycle over and back. So this is where the climbing began at the start of my house. And my house was built, as I showed you the image at the start, in this field. I inherited this site and I was really lucky to have good south-facing access overlooking these lakes. My architect was Niall Smith in Kingscourt. And we come up with some doodle drawings and sketches of what he was thinking would be suitable. I gave him my ideas and he came up with his ideas. And then my wife intervened and she took over. And well, let's just say we came to a compromise. So we can see here, this is the section showing the house. It's a vernacular design based on the local farmhouses of the area with the gables and so on, but has a contemporary type of style to it. So we have a garage here on the north orientation. We have the utility, bathroom and so on the north elevation. And then this is the south orientation where we have open plan and we have bedrooms upstairs here. This gives you a better picture here. The timber frame company I worked with was TimberTech Homes, very good with Fergal and the team. This is one of his 3D sketches showing the plan of the house. So we are on the southern orientation here with a carport and then the garage at the back. This just gives you an idea of elevations and some of the details that we had to work with. So in the house, basically on the ground floor, from the outset, like any of you accustomed to Passivhaus are very familiar with, we had to carry out a red line rule, which is relatively straightforward. The house is pretty much 2 square boxes side by side. And that was relatively straightforward on the ground floor. But on the first floor, my wife, who was always right and wanted a room above the kitchen here, which I wasn't too sure about. And I was being selfish, thinking about airtightness, thermal bridging, and thermal continuity. But this room she wanted to add above the kitchen in the open plan, which meant we had to create a link from this block to this block on the first floor, which meant we had to cross the airtight plane, which I never advised, but we did that in my house. And that meant we had to make plans on site before we got the site on site and to make sure we executed that detail correctly, which I'll show later on. So here we can see the site beginning to be dug out. Note the bike upgrade, the 40th birthday had passed. The foundation went in, it was a passive foundation that went in. And during that time, we had a heat wave. So there was a delay in getting the screed poured, and it gave the heat pump company an opportunity to create a drone shot just of the foundation and their work going on. So that just gives you an idea of the passive raft going in. I'll just move it on a little. So that just gives you an idea of the weather. We're very lucky. It was very good at the time, and that all went well, thankfully. So in terms of the wall build-up on the house, I had a plasterboard inside. I have a service cavity, either 50 or 80 millimeters, depending on the location, filled with Thermofleet, the sheep wool. Then I had a certified airtight racking board on the inside, sealed at the joints with the Proclima tapes. Then I had a full fill 225 stud filled with blown wood fiber called Gutex thermofiber pumped in the cavity. Then I had Gutex insulation called Multitherm on the outside, a Proclima Solitex humidimembrane on the outside, a vented cavity. And then on the outside, I had a mix of finishes. I had cement board, I had larch, or I had a concrete block with stone in front of it in some areas, and this vented cavity. So the U value on the wall was 0.11. On the floor, the U value was 0.09. I had a passive slab. You can see here the key continuity details here between the external insulation meeting the insulation on the floor. And the frame was getting ready for site by Fergal and the team. So I went and visited one day, had a look at it, and there's Fergal making sure everything's in order. And the crane was arranged by the timber frame company. They erected the panels, and during the process, it was done over a day and a half. The full frame panel was erected. We could see the detailed work by the team at TimberTech here, putting in Solitex Plus as the airtight lap between floors. So the guys in TimberTech were very tedious and careful with that. That's an absolutely vital part of the process. Also note on the timber frame panels, it's an open panel. In the factory, I instructed the guys to pre-drill the panels in preparation for the pumped insulation at a later stage that's going to go into the panels. I had Roman support of Clima House with me there the day the frames have been erected. just making sure a few details that were quite complex, such as the loop I was mentioning earlier on, that we absolutely nailed that junction. Because if you don't get it right at this stage, it's really difficult, if not impossible later on, to get these junctions correct. So it's very important to make sure we cover all these angles and address all these details correctly. So this is the connection that I mentioned between the two blocks that was quite intricate. And here we can see the floor panel that went in. We had a lap going from downstairs to upstairs on both sides, and we had the lap from the two blocks returning back to the inside here. Then we had the wall panels go in. So now we return this up against this and up against this, and this is the certified airtight racking board that we're gaining our continuity with. But that needed to be watched. You had to be like a hawk to make sure, you know, later on plumbers, electricians, or other trades don't damage that. Just had to be careful. This is a large glulam beam that went in at the ridge of the building. And I really wanted to expose that at the end of the project. I didn't want the plasterboard to cover it. So they carefully put it in, but I just showed that image and I'll come back to it later to why I show it. So it's just a very brief video showing that day when the frame was going up. It's just a few drone shots I took on the day. You can see the panels all pre-drilled. The guys carefully managing the panels on the site. And yeah, you can it just gives you a feel for the processes and the time and the skill that's needed to get all that right. So on the building, I had two roof types. I had a cold roof on the bedroom side, let's call it, and on the open plan, I had a warm roof. I also had a flat roof, a hybrid flat roof, where I insulated above and below with full fill insulation. I have data loggers and monitors in them, and they're all working really, really well. I also Wi-Fi modeled a lot of the details, and just to see how they correlate with the monitors I've put in. It's very interesting, but I'm not going to go into that now. But here we can see the roof slates, the tile battens, the counter batten, the Solitex Plus Connect I used, which is a pre-applied tape on it, above the Gutex multi-term on the outside. Then I've full fill thermofiber. So this is 80 millimeters and 225 of blown wood fiber. Then I have the Intello Plus membrane for air tightness and vapor control here, an 80 millimeter batten and plasterboard, and the heat recovery ducting ran in here, as well as the insulation I used there was a sheep wool. According to the EPD, if I use that as a reference, the environmental product declaration for the Gutex boards, I calculated that based on the amount of these boards I used, I sequestered about 8,500 kilos of carbon. That's locked up within, instead of giving off carbon and emitting carbon in the production process, my fabric has sequestered within that Gutex 8,500 kilos of carbon. Just to explain that a bit more, the Gutex insulation, it's made from wood, and as such, for every ton of carbon, it contains 3.67 tons of CO2, which is sequestered. So that's for every ton that's quite significant over the whole build process. And by using this wood, you effectively extend those carbon savings over the lifetime of the building. So for a U value of 0.18 for these 4 insulation types, you can see the negative carbon effects, the sequestering effect of using a natural insulation. Could be cellulose, it could be cork, or it could be hemp or jute. There's many forms. Over the wood fiber, then I applied a wind type membrane, the Solitex Plus Connect, which is a pre-applied tape. So I don't need to be taping joints. It's just a double-sided tape already there. So it's very easy to get wind tightness with that. On the cold roof, on the other hand, I just ran the felt all the way up the roof. I had a counter batten again, and I used about 450 millimeters of the Gutex thermofiber open blown in the attic, which I sheeted out at a later stage. And then I had Intello Plus on the underside, linking into the air barrier on the wall. And there you can see the roof. Then I spent about 4 or 5 weekends with my brother-in-law, Paul, who's a roofer. I had a great time slagging the engineer, trying to put slates on the roof, but I did my best, and we spent a few weekends doing that. So we used Sembrit slates on the outside and just covered it all. It was pretty straightforward, but we had to be careful with making sure we put grommets in specific locations for soil vent pipe, as well as for the heat recovery exhaust. So I had to pre-plan where to locate it early on, these grommets, just to give good wind tightness on the outside. And there you can see the roof almost finished. So then we got weather tight. We got there's my two girls. We got the windows in and the doors in. And then the air tightness work could commence now that we were weather tight. So the key for air tightness, of course, is coordination with the electrician, the plumber, the plasterboard installer, the glazier, everybody. So we had regular meetings on site to make sure everyone knew what they were doing and where the air barrier was and what the consequences were. Basically, if you found a leak, just let me know and I'll fix it. I'm not going to take the ruler out. I just want to know where the leaks are and we'll fix them. So then we got working on the air tightness. I started fitting the Intello with Roman. You can see Roman at that ridge beam, putting in the membrane in the open plan, gluing it to either side with some RCF. And then making sure in the ends, we seal the straps, we seal the joints in the certified airtight board. And later on, the blown thermofiber, the wood fiber is blown in here, and then just a patch is put over this. So here you can see the membrane fitted throughout that whole roof, and it's finished. Key point that's often repeated, but planning for services and making sure you put in these service battens, it's just absolute gold. It's critical for all the electricians and plumbers that come at a later stage. As you can see here, the electrician, it was his first Passivhaus, but he was an absolute joy to work with that I had. Worked really well and very enthusiastically embraced the principles, looking for grommets and just making sure he absolutely took care. But you can see the benefits of these battens for services and just good care and attention to detail around your openings, using the right tapes and making sure you press them firmly home when they're applied. Another point here is for the valves, for the supplies and exhaust for the heat recovery unit. I used the Epdm Grommets. I could have used tapes, but these grommets just give far better flexibility for the electricians or plumbers later on if they have to move stuff, and it just is far easier and quicker to fit. A key point was to make sure the attic hatch was fitted airtightly. So this attic hatch comes with a sealing system. It's certified airtight and pre-insulated, and that's what I used in the attic. It's called a well-hofer attic hatch. For tricky junctions that you just couldn't avoid, like where you've manifolds or a few pipes coming up through the screed, I used the Aerosana Viscon. This is a certified airtight paint around these points. Through the whole build process, I had regular training sessions with builders, local architects, planners. I invited the local councils in, and people came from Dublin and even from Monaghan, Barry, people came down to some of the open days. And this is one open day I had, and there's a video on our website showing that, where the speakers from the ventilation company, the heat pump company, the window company, the architect all gave presentations on the day. And that was really, really rewarding, just to share the information with them before the plasterboard went on. The heat recovery units in a press, it's easily accessible. I used a Brink Renovant Excellent 450, and you can see where I live. It's quite rural. There aren't any buildings near me, but even after earlier this year, this is the pollen filter after 3 or 4 months. So it just repeats that necessity to maintain these units, to make sure you change the filters regularly. But I have 2 of my 3 children have asthma. And since I moved into the house nearly 2 years ago, we haven't had to use the inhaler once. So that's testament to the air quality in the house, the comfort levels, and just the benefits of having these systems. For hot water, I have an air-to-water heat pump called Daikin unit, and it supplies what little heat I need. I put in underfloor heating on the ground floor. So in terms of challenges, there are numerous challenges, of course, like any build process. Going back to our friend here, putting in the beam, what did I forget here? Bonus points for anyone that can see it. I forgot to put the lap in at that point. That's the one point I forgot the lap, which meant I had to spend about a day and a half tediously going around this junction at night, making this airtight later on. But there you go. So everyone is open to missing something, and you can see there is ways and means of getting over this. But that was one point that I missed. Another point to be mindful of is subcontractors on the site. I went through in great detail with the company fitting the ducting about being careful with these pre-applied airtight laps above some of the top rails. And not only was the top rail butchered, but the lap was also badly damaged. So that had to be fixed later on. And we did fix it and retrieve the situation. But you can see the need for oversight is critical on any build, Passivhaus or anything. And I said to the electrician, he was excellent, but he just had one thing here. I noticed this cable coming through a top rail. So I spotted that, and we could easily access that from above and seal it. You can imagine later on, it would be a bit tricky to seal from below, and then you could get the resultant leakage through the joint in the timber. I know that sounds a little obsessive, but we're all a bit obsessive about these things in the Passivhaus world, I find. Some areas we couldn't get the grommets in, like there was a transition of the heat recovery ducting from the 2-story block over to the open plan, and the ducts were coming down this wall. So we used this butyl tape called Extra Seal Mag Off, and it's really, it doesn't look the neatest, but it's a really effective way of sealing around these awkward junctions with a butyl airtight flexible tape at them points. Another challenge or slight oversight was we didn't put certified airtight boards in this position on the wall, whereas it was to this point. OSB was used here. So we had to put the Intello in front of the OSB to prevent air leakage at that point. It was just not a large area, but nevertheless, we wanted to make sure it was airtight. So the transition in elements, sometimes that can be a bit tricky. You could think you're on an external envelope when you're on the plans, but that was actually, you would think that's an internal wall, but it's actually an external section. So once we made the building airtight, our blown Gutex arrived, the wood fiber, the loose fill wood fiber arrived, and it was going to be fitted by Roman. And within that lorry, we have 1,650 kilos sequestered carbon within the thermofiber. And the thermofiber comes in these bags. If you just cut the bag, we put it in the hopper mixes it, breaks it down, and then Roman pumps it in and fills the cavity. So here we are. This is another training day where we fitted the thermofiber. So I'm actually pumping it into this cavity here, filling the stud. It's 225 deep with the Gutex thermofiber. So you can, this stud, I think it took about 60 or 70 seconds to fill a 225 stud. You can see there it's filled at that side. And on this side here, you can see Roman showing this one here. Can you hear that? So we're just showing behind the Intello. This is the pumped blown wood fiber. You can see it's fully self-supporting. There's no settlement. The minimum density is about 32 kilos a cubic meter, and it has an ETA approval, and it's really good. It's really nice to work with. So once the thermofiber was blown, it was time to get the preliminary airtight test. And Mark Shirley from 2AVA came up and carried out a test, and we found some leaks at the usual spots, the drains, and some spots there weren't water in yet. Spots like that, we found a bit of air leakage. A few of the spots we found air leakage, but overall it performed quite well, and we got an N50 of about 0.38 at that stage. Then we proceeded to fit the sheep wool in all the service battens. So myself and my 3 kids, who I paid handsomely, installed the sheep wool, though I promised the 3 kids didn't go up here. I did that part. So once that was done, it was slabbed, and we got our final test done. So in terms of the building itself, myself and my colleague Joe in the office, we carried out an exercise where we looked at the house in terms of its performance in relation to deep. And by inputting the values to deep using the local Irish weather data and the latest electrical cost consumption at the time from the SEI, from the database from SEI, and based on a elemental U values of 0.1, we put in all them values and calculated the energy demand and the resultant cost. And if this house was built to a Q50 of 5, we would see the running cost was predicted to be €1,739 for space heating. But because it got 0.4, the estimated heating demand and the resulting heating cost was down to 328. So that just shows, everything else being equal, airtightness really does join all the dots up. It is that vital for making sure everything works. You know, your U values are important. Thermal bridging is critical to avoid, and making sure we have good ventilation. And the airtightness just ties it all together. In terms of the preliminary Passivhaus Sept, the heating demand is estimated at 11 and the heating load at 10, and the primary energy is at 95. So it ticks the boxes from that point of view, and I'd hope to get my Sept within the next week or two, the final certificate. In terms of the BER, it achieved an A2, just borderline A1, 28 kilowatt hours per square meter per year. But I do have provision to put PV in our lawn, and just below our lawn there's a space I'm ducting in, and I hope in the next 12 to 18 months to put PV and a backup battery, and hopefully we'll see. So this is the house taken about 12 months ago. This is it's moved on a little since then, but you can see it's taken shape. This is Lola, the dog, who's scratching to get in the door at the moment, and there, and you can see outside. It's just still work to do outside, but it's all small steps and taking shape. You can see these are plans for the future to put some wildflower and trees, put trees in here. That's what we're planning in over the next few years to do that, put trees and just wildflowers around. An area here, we're putting a pergola in here or some kind of shading. That's something we plan to do, but we just didn't do it at the start. But definitely in this southwest orientation, to reduce overheating in that room, it's an absolute need. So that's basically it. To conclude, airtightness, it really starts at the conceptual stage. A lot of you know this already. Start early and reduce complexity. But as I've learned on this project and many other projects, you know, buildings can vary in form. There's always room for simplification, and where complexity arises, embrace it, and you just have to go with it and really come up with as good a solution as you can beforehand and on site with the right team. At the drawing stage, plan the air barrier layer and highlight all penetrations, critical junctions, and save money. The rule I often repeat is, the easier the detail is, the less material you need, the less man hours you need, the better the result and the cheaper it will cost. The more complex the junction is, you're going to use more material, more man hours. It's going to cost more, and you'll likely get a worse result. So it's all about simplification if you're talking about saving money, and that's central to Passivhaus. Engagement, of course, is critical with all trades, and airtightness and controlled ventilation is the key link to healthy low energy buildings, which I've heard so many times, but now I'm actually realizing it myself living in the house. Airtightness really is the common denominator that links all trades together, and it's a real indicator of build quality. A really airtight house is a quality house. And clever design and a fabric first approach, this reduces operational energy by minimizing thermal bridges, air leakage, and design ventilation. But by building clever, it allows the specifier to optimize material usage and design with low carbon materials. I mentioned environmental product declarations earlier. These are now going to be absolutely critical going forward in making good judgment on what materials to use within our specification. They give a fully transparent information, and they help reduce greenwashing. It's going to lead to greater transparency as we get more accustomed to EPDs to aid key decision makers at the specification stage. And the development of EPDs will also encourage not only end users, but the manufacturers themselves to improve supply chains, reduce waste, and improve manufacturing efficiencies. Material choices have significant impact on upfront carbon emissions, and insulation choices also have greatly affect the carbon footprint of the building in terms of embodied carbon and operational emissions. So insulation can either be a significant contributor to embodied carbon of the building or a carbon sink, depending on the choice of materials. As an example of my house, over 10,000 kilos of carbon was sequestered within the insulation I used. Materials such as wood, straw, clay, and many other materials these naturally sequester and store carbon and reduce the carbon footprint of the building. I'm not going to bore you here, but one last point here is some research from the IGBC that 12 apartment developments in the UK and Ireland, the embodied carbon on their analysis, on life cycle analysis, ranged from 355 to 2,600 kilos of CO2 per meter squared per home, averaging 915 kilos of carbon per square meter. And this embodied carbon is equivalent to 114 years of operating the homes built to the current A2 standard. The one Irish apartment in that development had an impact of over 1,500 kilos CO2 per square meter, or equivalent to almost 200 years operating at the current standard. So this really crystallizes the huge impact embodied carbon is having in terms of the environmental impact of building. While the figures in Nordic countries are much more better. Based on 127 apartment developments, they had a much lower average of 365 kilos of CO2 per square meter. This demonstrates the huge potential and opportunity for improvement in tackling the carbon blind spot in the Irish construction industry. So this is a huge opportunity. We're coming from a base where we've quite high carbon intensity, but there's huge opportunities there to reduce it. Before I finish, Tim Martell has developed this software called PH Ribbon, which is a plugin tool for PHPP and allows you to make more informed decisions when you're designing a passive house on the environmental impact of materials over its life cycle. I think that's going to be a really useful addition to tackling embodied carbon in passive house buildings and all buildings. As this fella once said, we cannot solve our problems with the same thinking we used when we created them. So we need new thinking, new ideas, and new approaches to how we build. Finally, just a plug from the Irish Green Building Council. I'd strongly recommend this seminar, which is on tomorrow between 10 and 12. There's a link here to it. There's some excellent international speakers which speak very expansively about these topics I've raised about embodied carbon and life cycle assessment in buildings. Thank you for your time. And yeah, that's it.
Thanks, Niall. I think that was a really detailed look at your project. So thanks very much for that. Lots of really good information. A couple of observations. You know, you made the point about a really good timber frame company and that on-site supervision. Absolutely key. The airtightness team on site during construction, again, I think is really useful, even, you know, at the early stages, not necessarily when they're doing their main part. I kind of picked up on your no blame culture, which is again another thing that's you know, a key to success. We want to know where the problems are, don't we? And then of course plan, and then plan some more. So there are a couple of questions. There's still time for anybody out there if you've got a burning question to put it in the chat, and we'll try and get to them. You touched on it briefly, Niall, about overheating, and I was just going to ask, you know, had you future plans for some additional shading? A bit like my own project, we haven't quite got it there yet. But how did the building perform, just out of interest, in the recent hot weather that we've had?
Over in the open plan, I have a good deal of shading in that area, so that was not too bad. That was okay. In the lower room where I showed the pergola at the end, that did overheat, and I had to leave the doors open a little at night, and that helped to allow some cooling at night. So then I pulled blinds down during the day. So during the really hot period, it did. So my intention originally was to put a brise soleil in over them windows in that corner. That's on the southwest aspect, which tends to get most overheating if you're going to get it. But I'm going to put a pergola in there, so I have to come to an agreement with my boss on which she's not sold on the brise soleil, so it'll be a pergola, I think. Yeah. Yeah,
I think the recent heat wave just highlights the importance of solar or summer comfort, really, and this part of the world. Sometimes we just assume we're not going to get any sunshine, but of course we do.
One observation on that, Simon, was in the room above the kitchen. The room in the attic was very cool, and it actually was a very comfortable room. and I think that's very much down to the high heat storage capacity of the wood fiber. It has it's very effective decrement delay. Of course, you need shading, but the materials are conducive to absorbing heat and controlling its passage very effectively. So, but one other point that John Moorhead told me, I don't know if he's listening there, but he told me earlier on before I built, and I didn't do it, but I should have done it. And complete oversight on my side was to put a high level ventilation in the open plan. And I'll have to put that in really. I think it's a good idea just to get that nice stack effect as well.
I've got a question just come into the chat from Richard Kenny. He's asked how vermin-proof the construction is that you've used.
Yeah, no complaints yet. From my site like that, there's no signs of event like that, and I live very near 3 lakes with a farm nearby, so there's plenty of them outside. Now, I do have a cat and I do have a dog, but the cat's outside most of the time. But I don't have any issues with anything like that. The wood fiber board and the wood fiber, it's pretty inert as a material. When it's produced in a process where it's heated, and that breaks down the proteins within the material. So there isn't any active food source for like insects, for example. So it wouldn't be attractive to them any more than your conventional insulations. But if vermin want to get in, they'll get in. In my old house where I lived for 15 years, it had mineral wool and your standard insulations, and I had mice in there, and I was living there for longer. And in my college days, I lived in a block house, and I was the local mouse catcher in the house when I was in college. The other lads wouldn't. So if they're going to get in, they're going to get in. But they're definitely, so far, fingers crossed, touch wood, I haven't seen any vermin in here.
Stuff. We're due to go to some breakout rooms, but I'm just going to ask very quickly 2 questions you might give a brief answer to. One, Colin Hart asked about the monitors, the data monitors that you've installed. What are they, and what data is coming back? And Nico Mackin, apologies if I've got the name wrong, had asked what was the kilowatt size of the heat pump?
The heat pump, I think it's a 6.8 kilowatt. I think it is heat pump. I think that's the exact size of it. And it usually, yeah, that's about it. It's 6 point. My energy bill for electricity, now I don't have PV in yet, but it's coming. My last energy bill was about 150 euros for 2 months. In winter, it averages at about 200 or 220. It's around about that every 2 months. The other question you had there was about the
just about your data
yes,
monitors.
The monitors I put in are Tramex monitors, they're called, and I embedded them in the OSB. So in my flat roof, I have a hybrid flat roof. So I have insulation above the flat roof and below. So I've blown wood fiber about 280 millimeters below the flat roof. I have an OSB deck with a vapor barrier. Then I have 100 millimeters of phenolic, and then I have a flat roof membrane. And I put the data logger at the critical point beneath the OSB, and that's feeding back inside to my phone. And I put them in different positions in the house. And it's measuring temperature and humidity and that stuff. So I Wi-Fi modeled these details beforehand, hydrothermally, and then I put them in, and just to see how they performed as well.
Thanks, Niall. And one question that came in from Ronan near the start, and maybe an opportunity for you to plug some of your training. Ronan asked if there are any courses or similar information for a self-builder not in the trade looking to, I guess, skill up before breaking ground, so the things to look out for on site. I know you guys do a lot of training throughout the year.
Yeah, thanks, Simon. Thanks for the question, Roland. Yeah, we have a training centre in Athboy in County Meath. So we can provide training there if you contact us directly, or else we also have remote training online. We've done that over COVID. It's worked actually very, very well. On our website, ecologicalbuildingsystems.com, under training, you'll see details. And we also have a technical team that can go to site if needed to give support. Another organisation giving training are the ETBs. They're giving training now. You have the Limerick Offaly ETB. You also have the Wicklow, Waterford, Wexford ETB. and these are rolling out training as well. So yeah, so that there's more and more opportunities from public bodies to give training, as well as manufacturers like us as well.
Okay, Niall, thanks very much. I think we'll just close the questions at that point. If there's any others, I'll pick those up and we can maybe answer those offline to those. There's a couple just popped in at the last there. So we're going to go into some breakout rooms just for 5 minutes to a bit of meet and greet and talk to everyone, a bit of networking. And then we'll come back for Barry to close in about 5 minutes or so. So Yvonne, if you can bounce us all into some rooms, please.
Certainly, I'll open them there now. And